This video is about the composition of functions. I'm going to do quite a few examples, so be ready for that. A composition of functions is when one function is being plugged into another one. So please understand that the symbol in this notation is not multiplication. That's a little open circle. It almost looks like a degree symbol. It means the composition of functions. It's when one is being substituted into another. So for this one on the screen, f of g of x is how you would read it. And you start from the inside and work your way out. So what's happening is g of x is being plugged in to f of x. So I'm going to go over a few examples. First, we have f of x is equal to 5x plus 2, and we have g of x, which is equal to 2 over x minus 1. First, I'm going to find f of g of x. That means g is being plugged into f. In other words, every single x that you see in f of x is going to become g of x. Now, I've included the other way that you could see this written with the little circle. So please understand that both of these mean the same thing. So we have f of g of x, and g of x is 2 over x minus 1. So that means instead of 5 times x, I'm going to have 5 times 2 over x minus 1 plus 2. Now, I rewrote the 5 as 5 over 1, just for anyone who needs that when multiplying, so that you understand that the numerators are being multiplied and the denominators are being multiplied. And we could simplify this more and get a common denominator, but I'm just going to leave it like this. So that was f of g of x. Now, if we go the other direction, it would be g of f of x, which means f is being plugged into g. Here is your notation for that. There should have been a parentheses around the x in the first one. This is the notation, g of f of x. And so what's happening here is 5x plus 2 is being plugged into g because f is being plugged into g. So now, instead of 2 over x minus 1, the x in the denominator is becoming 5x plus 2. So the x is replaced with 5x plus 2, and now we just need to simplify as much as possible. So 5x plus 2 in parentheses or not in parentheses are really the same thing, because all we're doing is subtracting a 1 from it. And so it would simplify to 2 over 5x plus 1. So that is the composition when you're just plugging one function into the other. The next couple examples, I'm taking it a step further, and it's really not that much more difficult than these were, hopefully. This time, notice it's not f of g of x, it's f of g of 2. So, like I said in the beginning, you're working your way from the inside out. So with these especially, you want to start on the inside. On the inside, we have g of 2. That means you want to find g of 2, and then that gets plugged into f. So working from the inside out, we're starting with g of 2, which means the x in our new g of x function up here, g of x equals x cubed, is becoming 2 instead. So this is the notation, g of 2. That means every x is being replaced with 2. So now instead of x to the third, we have 2 to the third, and then that equals 8. So that was our g of 2. Now this was f of g of 2. And so now that we know that g of 2 is 8, I can rewrite it. Instead of f of g of 2, I can write f of 8, since g of 2 is 8. And this notation means 8 is being plugged into f of x. So instead of 3 times x, we have 3 times 8. Don't forget the plus 1. That becomes 24 plus 1, which is 25. Next is the opposite. Instead of g of f of 2, instead of f of g of 2, we now have g of f of 2. So starting from the inside out, you want to do f of 2 first, which means every single x in f of x is becoming 2. That would be 3 times 2 instead of 3 times x plus 1. 3 times 2 is 6, and then you do 6 plus 1, and that would equal 7. That is just f of 2, and that is being plugged into g. So now that we know that f of 2 is 7, this becomes g of 7. So now we're replacing the x in g of x with 7, just like we did before. Now we have 7 to the third power, and 7 to the third power is equal to 343.